Hi everyone, this is Gigi from Kauai Community College. In this video, we are talking about the instantaneous rate of change and the tangent line. Okay, so the objectives would be to talk about the slope of the secant line and to use it to find the slope of the tangent line. Then we will proceed to find an equation of that tangent line. An application of this concept would be the velocity function. All right, so back in algebra classes, you have seen the difference quotient. Okay, so suppose you have a point here on the function f of x and another point there on that function. The first x value, we will call that x, so the output is f of x. We would go out to the left or right, but in this case, we'll go right an h unit. So we end up with the second x value of x plus h. Therefore, its output is f of x plus h. Now, this blue line is what we call the secant line. So then the slope of that secant line is what we also know as the average rate of change, which is change in y over change in x. So you'll have y2 minus y1 over x2 minus x1, which would just be the distance h. So what we have is f of x plus h minus f of x, all divided by h, which represent change in y over change in x, and we define that as the difference quotient. That's in an algebra class. Now, what we are going to do for this class in calculus is we are going to use the concept of the slope of the secant line and the concept of limit to find the slope of the tangent line, or to define the slope of the tangent line. So the tangent line is the line that goes like this. Say the tangent line at the point x would be this green line right there, right? Now our blue line, if we let h, that h distance, be smaller and smaller. So suppose h is this big, then that x plus h point would be right here, and we would have that secant line. Well, that doesn't look like the green line yet, right? Now let's h be even smaller, so close to x. Let's say it's here. Then the secant line will now begin to look like the green line. Okay, so the concept is if h is approaching 0, which is really small, then the blue line will look very much like the green line. So that the slope of the secant line as h go to 0, and we would write the limit as h go to 0 of the slope of the secant line will be the slope of the tangent line at the point x, f of x. So given that, and if you have a function and a point, then you may be able to find the equation of the tangent line at that point. Okay, so for here, there's the function, and we're looking for the tangent line when x is 1. When x is 1, f of 1 is 1 plus 2 minus 5 is negative 2. Okay, and if we actually look at the graph, and it's nice to look at the graph, you don't have to do it that way, but it's nice to just go ahead and graph it and take a look and make sense of it, right? We know that the definition of slope, the tangent line, previously defined as the limit as h go to 0 of f of x plus h minus f of x, all divided by h. Now, the function is a parabola. That's the red curve there, the red U shape. The tangent line is the green line there at the point 1, -2. So we're looking for the equation of that green line. Now to do that, we would say, well, let's go find the slope. The slope is limit as h go to 0 of f of x plus h minus f of x. F of x plus h would be wherever x is, you would put in x plus h. And minus f of x, and f of x would be the function itself, which would be x squared minus plus 2x minus 5, all divided by h. Now what we're going to do is we're going to go ahead and expand that out. So then the limit as h goes to 0 of, when we expand this out, this would be x squared plus 2xh plus h squared plus 2x plus 2h minus 5 minus x squared minus 2x plus 5. And the wonderful thing about this is a lot of things will cancel. For example, -5, +5. And then we will see that minus 2x plus 2x minus x squared plus x squared. Everything else left over has an h in it. So we're going to go ahead and divide by h. When we do divide by h, we will have the limit as h go to 0 of 2x plus h plus 2. And if h is really small, approaching 0, then this right here is approximately 0. So you will get a slope function of 2x plus 2. Okay, so that is a slope function of the tangent line at a given point x. Now, we are looking at when x is 1. So when x is 1, the slope at that point is 2 multiplied by 1 plus 2, which is 4. So we would now and say, well, you know, the equation of a line is y equals mx plus b. And y is -2, which is that green point right there, is equal to the slope we just found, that is 4. X is 1 plus b, so b must be -6. Therefore, the equation of this tangent line at x equal to 1 is y equal to 4x minus 6. And let's take a look right here. Look at that. Y-intercept is at -6. And the slope is up 4 over 1, up 4 over 1, up 4 over 1. Perfect. And that is the correct answer. Now, not always that you are able to look at the graph and be able to tell the equation of the tangent line nicely like that, right? But so that is why we need some calculus and some algebra there to do this type of problem. All right. So here is another example. The function is f of x equal to square root of x, and the point is x equal to 1. When x equal to 1, f of 1 is 1. And we're looking at the square root function, right? Again, the slope of the tangent line at any given point x, f of x, is the limit as h go to 0, f of x plus h minus f of x, all divided by h. So we have limit as h go to 0 of, here we have square root of x plus h minus square root of x, all divided by h. Now, you would say, oh my gosh, how are we going to find the limit of that, right? The trick here is rationalizing. Multiply by 1. When we multiply by 1, we are looking at multiplying both the denominator and the numerator by the conjugate. So that would be this right here. Square root of x plus h plus square root of x divided by itself, that's 1. And this right here on the top is the difference of 2 squares. So that would be the limit as h goes to 0. And the difference of 2 squares would say a plus b times a minus b is a square minus b square. So you square each one of these here, each one of these term here, and the square root will be gone. And that was the point of doing that. So you will get x plus h minus x, all divided by the thing on the denominator. You multiply that across, but I'm not going to distribute. Keep the h on the outside. We have x plus h plus square root of x right there. The numerator will simplify to be just h. And then h divided by h is 1. So this is just 1 over square root of x plus h plus square root of x. Well, imagine when h goes to 0, then you will have the values of that being just like square root of x. So then you will have 1 over 2 square root of x. That is your slope function. Okay, so when x is 1, your slope would be 1 over 2 times square root of 1, which is 1/2. And then again, we could say y equals mx plus b. M being 1/2, x is 1, and the y value is 1 plus b. So b is equal to 1/2. So then the equation of this tangent line is y equals 1/2 x plus 1/2. Does it look right? Well, this right here is definitely 1/2. And the slope would be up 1/2 over 1, or you would say up 1 over 2. That is the slope of that function. So the answer we are looking at is y equals 1/2 x plus 1/2. And that is pretty nice. Now, if you want to clear the fraction and make it even nicer, then we would say multiply everything by 2. So then you will have 2y is equal to x plus 1, or we would say x minus 2y is equal to, or you can say negative x plus 2y is equal to 1. And that looks a little bit nicer that it doesn't have fractions, but it's up to you in which form the equation is that you want to deal with. Okay, so some of the things that you want to look at really is in an algebra class is to really learn how to rationalize. Okay, Okay, so an application of the instantaneous rate of change, or that slope of the tangent line, okay, that means the rate of change at an instant moment, is when you have the distance function, right? We know that distance divided change in distance over change in time will give you an average velocity, right? So, or you just say an average speed. Okay, now that's how we calculate speed. Now, when we do have that instantaneous rate of change, we can call that the velocity function. Okay, so here the velocity would equal to the limit as h go to 0 of s of t plus h minus s of t divided by h. The same definition of the slope of the tangent line. Okay, do a little substitution, a little bit of algebra, and we can see that this right here is gone, right? Everything have an h in it, so you divide everything by h and you will get that. The t is gone. And then when t goes to 0, 0 times 4.9 is going to be 0. So you'll have just 9.8 times t. So after t second, we know that this rock is traveling at the speed or at the velocity of 19.6. The speed of that rock is 19.6 meter per second. Now it's going down, so you might say the velocity is negative 19.6 meter per second. All right, so that is something that you will use in a physics class. So that is how instantaneous rate of change will apply in your science classes. That's kind of fun. Some algebra review for this chapter: difference quotient, rationalizing, complex fractions, and also go and look up sum and difference formula for those trig functions again. Okay, so if you could review these topics here in algebra, life will be a lot easier for you in this section.